been involved in all 10 Podcar City conferences, but this time I have a different subject than before. So it's about synergies between autonomous cars and podcars. Can we benefit from each other's developments? And I come from this from many angles. I started with transit route planning, making bus networks during my Volvo days. That's now part of Visum package. And then I did taxi fleet management for the 3 biggest cities in Stockholm. And then personal rapid transit and simulation models for that. And now recently I'm working with shared autonomous taxis. So now these are all coming together. They're all being integrated, and my subject is how can they learn from each other. This is about transit going autonomous. Not only cars will be autonomous, also transit. And self-driving cars will not only be private, they will be shared, so they will be public. We have automated transit networks, and how these developments support each other and what the effect will be. Is it going to be good or bad? So, traditional transit, as you know, it's about bunching people in space and time so that we can save money on the operational cost. So we have large units with long headways, so we don't have to pay so many drivers. And we're serving corridors, not areas. And if people want to go to somewhere that's not along the corridor, they have to change to some other route. And vehicles have become larger and larger. I used to be with Volvo, and we were earlier with articulated buses, and then double articulated buses, 24 meters long, all in order to save on driver's cost. Now, this traditional transit can evolve and is evolving with intelligent transport systems. So the first thing we had already in the 1980s was steering control. So self-steering buses, and we have headway control, so we have better traffic management, keep equal headways between buses, and there are anti-collision devices. We have dedicated lanes, and now we are getting driverless operations. That particular bus is going from Schiphol to Amsterdam, mostly on a dedicated bus route. So it's a bus rapid transit service. Now, if we can do this without drivers, what does that mean? It doesn't only mean that we save on the driver's cost, which is, in the case of delaying, was 65%. So that's a huge difference. But if we don't have that cost, there's not so much reason to run big buses anymore. We might as well run smaller buses and have more of them, and so that they could serve more often, so we have shorter waiting times. And also we don't need so much layover time at the end of the route. They don't need breaks. They don't need refreshments, they don't need the toilets and all that, so they can be running all of the time. And they don't need to go to points where they change drivers, so the scheduling is much more flexible because it's difficult. If you have smaller vehicles at high frequency, you don't need a timetable actually. You might as well go when people want to go. And you don't even have to follow the fixed route. So if on this particular trip someone is going off the route, well, we take that detour. So these are all opportunities when you get rid of the drivers. and by coincidence it gets more and more like ATN systems. On-demand, flexible routes. So here are some examples. First is by Easy Mile from that's Dubai. They claim 25 kilometers per hour in a dedicated space. I'm not sure how protected it is. There are clear markings on the ground, but I'm not sure who is allowed to cross there. And there's one by Navia in Perth, which claims to run 15 kilometers per hour in mixed traffic. And you cannot do much faster than that if you're not sure that you don't have pedestrians and dogs and children running out. So it's even if you have all the sensors in the world and all the GPS and all the intelligence, children can be unpredictable, and so you can't run fast in an unprotected area. So much about traditional transit and how it can evolve. Now let's start from the other end. Self-driving cars. That's the big hype now. Whereas before, when we were speaking about podcars on guideways, everyone said, well, how do we know it's going to work? But now when the car industry says that we can do it in mixed traffic and full speed and unsafe headways, and say, yeah, great, come to us and do it. Suddenly we all trust it. So there is this race now between countries who is the most permissive, the most liberal, because then our car industry will be ahead of the others. So we have Google, Tesla, Mercedes, Volvo, and Audi, BMW, all of them are in this race. And one advantage when we have self-driving cars, they could then run empty to the next task, for the next customer or whatever. And it will be, as a taxi, it will be much cheaper than the present taxi, because I think in the case of a taxi, the driver cost is at least half. It may become legal maybe in 5 years. That's the expectance. Before the 5 years, we'll have a lot of tests and exemptions, temporary permissions, and a driver being ready to take over and all that. But the fully driverless cars, the best estimate I've seen is 2021, and then still in fenced areas, so not everywhere. There are levels of automation, and the traditional car manufacturers, they go step by step, starting by more and more driver assistance. So headway control, automatic stop and go, and then lane departure warnings, automatic steering, and so on, until the end result would be the full autonomous car. The problem with the intermediate step is, how do we keep the driver alert and ready to take over when he will? It's difficult, even if you want to. It's difficult to be focused and concentrated for a long time when you don't have to do anything. So you're tempted to do other things, and then suddenly you have to make a decision in 2 seconds. Whereas others like Google jumped over all the intermediate step and going straight on to the final result with full autonomous, so they don't even have a steering wheel, and so they don't have the problem of the interface with the driver. We'll see what the development will be. We did a study at the University in Stockholm. What would happen if we had shared autonomous taxis in Stockholm, and assuming that every commuter that's using his own private car now would leave his car at home and take this shared autonomous taxi. That's an optimistic assumption, but what if? And the results were remarkable in the way that each taxi could replace 14 private cars. That's better than the other reports I've seen have been about 10. But we were good at ride sharing. So that looked very well, good. And the parking could be reduced by 95%, and that's the main effect. At least these cars, these taxis, they don't park. They go to the next customer. We could reduce the number of vehicle trips by ride sharing by 30%, but each trip would get longer because of detours. And also we had to do empty running in between trips. So if you add those up, we have the same mileage as before. So although we saved almost all the cars, we have still the same traffic. Each car makes more trips, and we might even have more congestion than before. And this was with very optimistic assumptions that everyone would take this and leave their car at home. In reality, not everyone would do it, so then it's more difficult to combine, to match the ride sharing, and they may also take some passengers from transit, and that's not good. So now I'll switch on to automated transit networks. They are driverless, public, they are networked, they have their protected right-of-way, they go on demand, they go non-stop to destination, and they can be individual or shared. That's PRT or GRT or Podcars on guideways. So, and they have been running for over 40 years, and they've done 2 million miles, and they have no accidents, which is remarkably good record. Modern PRT systems are smaller, lighter, and they can also be personal or shared. I'll say a few words about control since it has implications on car traffic. With one of the control options is asynchronous control, and that means you can depart when it's free, when the line is free, and you may have to slow down in an intersection, and the conflicts are resolved locally in the intersection. And so there is no central control for all the movements. It's taken care of locally, and so it's distributed and scalable without limit, and the central control is only for empty trips, and that has been developed for PRT and applied for PRT, and that could be applied for driverless cars in the same way. The empty vehicle management is important to minimize empty trips and to cut the waiting times. That's an interesting optimization problem. I'll not go into that, but we have very sophisticated strategies for that. I'll move on to ride sharing, which is another thing that was developed for ATN systems. It occurs spontaneously in all the PRT systems that are operating over the world. People ride share, and we don't tell them to. We don't say that this is a public system, go together, fill up the cars. They just naturally do it. It's like an elevator, but it still departs on demand. It can make an extra stop if necessary, and particularly when you have, people would say that, what if you have a train station? You can't handle that, can you, with small vehicles? Actually, that's better when you have transfers from other modes, because then you have more people coming at one time. We can load up with empty vehicles before the train comes in, and it's much easier to match them when we have many at the same time. We will fill up one vehicle for each destination, or more vehicles for each destination. It's much easier than ride matching when they come spontaneously. So this can be applied to autonomous taxi as well. So these are some ride-sharing strategies. One of the findings was that if we could get people to walk to a station, we can do much better ride-sharing. Door-to-door taxi is not good for ride sharing. We only achieved a factor of 1.5, so have 1.5 passengers instead of 1. That's not good enough to compensate for the empty vehicle running. But if you can get people to walk maybe up to 400 meters to the nearest taxi station, then you can match them much easier. So that's much more efficient. Then you can get a factor of 3 for ride sharing, for PRT or for taxi. So now about synergies. It's good that the car industry is doing this because they have a lot of money. And they will develop new components that are low cost, and they will standardize communication protocols that we all can use, and they have a strong industry lobby. So they will go to government and say, support us because this industry, we have so many employees, and the government will then change the regulations so that they get permitted. They won't say that, well, you have to be at least as safe as a rail, because then all the roads in the world would be blocked if people had to have safe headways between cars. It wouldn't work. So they can't do that. So they have to be more liberal. So from the other end, from the Podcar side, we have proven reliability with 200 million miles instead of 2 million miles that Google has now, about 2 million miles. So that's a factor of 100 more reliability. We have already the distributed control. We have the empty vehicle management that can be applied for taxi as well. We have the ride-sharing strategies that work equally well for taxis. And we have existing standards. We don't know what regulations will be for cars, driverless cars, but we know what they are for guideway systems. And we have a certification process. It has been done a number of times. We know what to meet and how to do it. It's not easy, it costs money and it takes a lot of documentation and it's a long process, but we know how to do it. So, now I'm talking about combinations. We can use autonomous cars for PRT. So we can run autonomous cars as if a PRT system. Okay? So we already have the car, they're already electric, they can navigate on reserved lanes, we have the sensors, we have the communication, onboard control, we can do slot allocation in the intersection, and we can do the empty vehicle management. So that's a possibility. We can take all this from PRT to autonomous taxis. And this is an example of a Podcar that was taken off the guideway and adapted to be used on a road. That's the Ultra vehicle, which is now being converted to be a driverless car in mixed traffic. And we have applied the simulation models for automated taxi on roads. And these developments will converge in the end into dual mode. So if you're coming from the car side, you drive manually on road, and then you decide to, maybe it's good to have an elevated road somewhere so that we can bypass the queue here. To add capacity, to bypass queues, and you can charge for it. So, I mean, it might be a good investment. Wherever there is a long queue, I build an elevated guideway and say, you can use this guideway, but pay me first, and I'll make money on that. Or if you come from the ATN industry, you already have the guideway ATN. Maybe you make it possible to take it off the guideway, go the last mile. I'm not saying you should do it, but it can be done. And so then it will be your first and last mile to the ATN network. Whichever way you see it, it becomes the same thing in the end. You have a dual mode system, guideway and road. And the good thing with that is we have to harmonize the rules, the regulations. So on the one hand it's good and more flexible. On the one hand it's bad because now people will move away from the cities, make longer commutes, they send a car home. It will take some passengers from transit, and there will be empty running, so there will be more road traffic. So automation is coming both for cars and transit, and they can benefit from each other. And we may have driverless cars by 2021, but it will increase road traffic, I say. It will increase, it will not improve congestion, whereas ATN transit is already proven, it's certified, it's available now. And in the end we'll have dual mode and harmonized regulations between rail and road. And when we get that, that would at least double the capacity of ATN systems. Because they have to be the same as for cars, and they can't be as strict as they have been with rail. So that way, the ATN systems you invest in now, in the future, they will at least double their capacity when the regulations get harmonized between cars and rail. Thank you. Questions?